Assalamu alaikum. I'm Rashid, and I'm a mechanical engineering student at Nairobi campus. Today, I wanted to derive for you why do we apply this formula in differentiation from first principle. Where did this came from? Remember that we have been differentiating that, we have been saying that dy dx is like you have differentiated a function. So I would show you why do we use this formula to differentiate. So suppose we have a Cartesian plane as shown. Therefore, then we are provided with a function of x with that curve. Let this be our function, our curve in that function. So let's say we have a point here. Let's call this a point x. So for you, since you can see here, we have a limit of h approaching 0, limits of h approaching 0, then it's when we all know that finding dy dx is like you are finding the slope, hence the gradient. And we know the gradient of line is just given by change in y all over change in x. So wherever you see change in y over change in x, and differentiation is just the change. Dy dx means just the change in y in terms of x. Now let's come and apply the determination of gradient to come up with dy dx. So meaning finding gradient is means just differentiating an equation. Now suppose h increases slightly by a value that is very small, and we assume that value is just very small, that it approaches 0. So assume this x just increases to a point that approaches 0. Suppose that is the point. So the increase there, the increase in x, we shall call it h. That is what h, that's what means here when h approaches 0. So this function, when you see that h, that value of h is just when h approaches 0. Now, let me show you how to come up with that function. So suppose this is x. Then, therefore, this one, it will be its y. But we know that given a function of y equals to mx squared, equals to ax squared plus b. Therefore, we can say this y being the function of x. Y is just the function of x, which y equals to ax squared plus b. So let's apply, instead for we using y, let's use y is always the function of x. So therefore, if this one is x, this one it will be just the function of x. When you use the function of x, you just get your y. Getting y is just using function of x, normal. So since this change is very small, and for illustration, it's difficult for we to illustrate it in this form, let's assume this small change. Let's exaggerate the small change being at a point so that we can illustrate. So let's assume the small change is at there. Therefore, the distance from here to here is h. So I'm asking yourself, how will we obtain this point? Since we know the length from here to here, and here is x, meaning adding h, you reach this point. So therefore, this point, it will just be x plus h. Since getting the value of y is just using the function of x, therefore, the function of this x, so where x has already increased by h, this h is very small. So since it has increased by h, therefore, getting y is just the function of this. Y at this point is function of this value of x here. Therefore, this is just the function of what? X plus h. Now, we have 2 points. We know that finding gradient, we have to look for 2 points. If you have the coordinates of 2 points, therefore, it's simple for you to determine the gradient of any line. So, we determine the gradient of this line. So, the gradient of a line touching the 2 points, it can be determined by change in y all over the change in x. So since y1 is here and y2 is here, we can call this being y1 or this being y2. Since this one seems to be greater than this one, let's call this one being y2. Therefore, y2, the change in y just taking y2 minus y1, which is just function of x plus h, we minus function of x. Then all over function, we change in x now, all over the change in x, whereby change in x is just taking x2, since this seems to be larger. When you take the larger minus the smaller, also here, you will do the same. Take the larger minus the smaller, which is x plus h minus x. But you have to show that the limits of this h, we don't know h is 0.00 what or 15, but we know h. For h, the limits of this h just approaching what? Limits of h is just approaching 0, very small. You just show that limit of h is very small, that it just approaches 0. Let's simplify this function. Therefore, for f, change in y over change in x, which is the gradient, can be given by limits of h approaching 0. Then we just take fx plus h minus fx all over. So x and x cancels out and remain with all over h. This is how we obtain that function. Since the change in y of changes is the gradient, and in differentiation, we find the gradient by differentiating a line in terms of dy dx. Therefore, dy dx is just the limits of h approaching 0 of fx plus h minus fx all over h. And we have shown that for we to determine gradient of a line is then simpler for we to do so. For more videos, I ask you to activate the notification after subscribing to my channel for you to be updated after any upload of my videos. So far, we have come up with this function. So I'll be posting more and more videos. So for me to improve my videos, my channel, I ask you just to comment. I'm waiting for your comments, and I'll improve my videos and uploads. So for those who need, maybe for I to know that you are interested just comment, like, and also share my videos and subscribe.